This video is about fairness related to TCP and UDP. Fairness means whether different participants of a network get an equal share of the transmission capacities which are available as a whole. On the slide there is an illustration of how two TCP streams behave when they compete for transmission capacity. On the x-axis we see the current data rate of sender 2 and on the y-axis the data rate of sender 1. The maximum data rate which is possible in the network is R. This limitation is maybe caused by a shared link to the internet, which is a bottleneck for the TCP connections. The best situation would be that both senders get a data rate of half R. Let us assume a start situation where sender 2's data rate is much higher than the data rate of sender 1. The sum of their data rates is below the maximum capacity. Both senders increase their data rates linearly as we know it from TCP congestion control. After some time, the maximum capacity of the network is exceeded so that there is segment loss. As a consequence, the congestion windows of both senders are bisected. In absolute bit rates, this implies that the bitrate of the sender with the higher bitrate is lowered more than the one of the other sender. In the following, both senders increase their bitrates linearly again. Then there is again a congestion window bisection after segment loss, and so on. So you see that a convergence happens so that the data rates converge. In general, TCP fairness holds also for more than two TCP streams, but it is important to understand that this kind of fairness is based on TCP streams and not on end systems. In an example, we have one end system which does a download via one TCP stream. On another end system, browsing is performed and the browser uses parallel TCP connections to download the web page contents. Since the fairness is on the level of TCP streams, the second end system gets a much higher data rate. You can discuss whether this is desirable. You may regard it as more important that web pages are displayed quickly rather than that file transfers are finished earlier. Another important point is the relation of TCP and UDP. UDP does not know a congestion control mechanism. This means that in UDP a data rate is predefined and UDP sends the datagrams using this data rate. This happens independent from observations whether there is loss or how much loss happens because UDP does not care about it. The consequence is that UDP streams can occupy as much network capacity as they want, and TCP just gets the rest of the capacity. This can also mean that there may be no capacity left at all for TCP streams. If there is some capacity for TCP streams, then the TCP streams share this capacity in a fair manner among each other.